Example 2 of balanced Redox equation continued. So like I was saying, I've added minus 2. So if you take this in now, this becomes plus 12 minus 6. And it has turned to what? Plus 6. Which balances this side, which is plus 6. So the number of charges now is now balanced. It is now balanced. This side is plus 6, the other side is plus 6. I will call this one equation 1 and call this one equation 2. So now check equation 1 and equation 2. Check equation 1 and equation 2. In equation 1, we have 2 electrons, while in equation 2, we have 6 electrons. Don't forget the rule. The number of electrons on reduction half equation must be balanced with number of electrons on the oxidation half equation. So we begin to think, what do we do so that in both half equations, their number of electrons will be the same? Check again. Equation 1, 2 electrons. Equation 2, 6 electrons. So what do you think we can do? I think that in equation 1, we are going to multiply the whole of equation 1 by 3. So that 3 times 2 electrons will give us 6 electrons. And we are going to multiply equation 2 by 1. So that 1 times 6 electrons will remain 6 electrons. Remember, we are trying to balance number of electrons on both half equations so that they will be equal. I said in equation 1, I am multiplying the whole of equation 1 by 3. So that 3 multiplying 2 electrons will give me 6 electrons. Don't forget that in equation 2, we have 6 electrons. So I am going to multiply equation 2 by just 1. So that 1 times 6 electrons will still give me 6 electrons. By doing that, number of electrons in both half equations will be balanced. Let us check how it goes. I have multiplied equation 1 by 3 and multiplied equation 2 by 1 so that the number of charges in both half equations will balance each other. If you check it, 3 will affect every other thing inside on that equation. 3 multiplying sulfur ion will give me this. 3 times this will give me this. 3 times 2e will give me 6e. And I call that new equation equation 3. The same thing with the reduction half equation. I multiplied it by 1, just as we have discussed. Multiplying it by 1 means everything will remain the same. 1 times 1 million remains 1 million. So everything remains the same. So I got the new equation 4. If you watch, the number of electrons in equation 3 is 6 electrons. Number of electrons in equation 4 is 6 electrons. They are going to cancel each other. The next step is to combine equation 4 and equation 3. Combine equation 4 and equation 3. You get the overall redox equation and we'll be done. Let's combine the two half equations. Combine equation 4 and equation 3. And it has been done on the board. I have done it on the board. Check it. Remember, combine equation 4 and equation 3. This is equation 4. This is equation 3. First of all, start with the reactant. I pick this. Sorry, this is minus. I pick this. Pick this one. The reactant of this one has finished. I now go to equation 3. Pick this one that is here. The reactant of that one has finished. I'm now going to the product. I pick this one, which is here. Pick this one, which is here. The product of that one has finished. And I come to equation 3 and pick this one and put here. That is the overall redox equation. Let's check further examples.